In the depths of our lakes and rivers, usually unseen, lies a breathtaking treasure, full of mystery, a puzzle whose way of life has yet to be fully discovered. This is the fascinating world of fish. About 100 species of fish and lampreys live in Germany's waters, a large number of which are threatened by pollution, canalization of rivers, and loss of natural habitat. But who takes care of the conservation of the unique underwater world? In Germany, it is mainly the anglers. There are about 3 to 4 million recreational anglers in Germany, about 1 million of whom are members of organized clubs. The anglers' expenditure finances 52,000 jobs in Germany, more than the rest of the fishery economy. Recreational anglers are also the most important owners of fishing rights. However, they are not only authorized to use the waters. The state fishery laws also make the fishing rights holders responsible for the conservation of the waters, including the fish stocks. In modern terms, the anglers are the most important managers of the fish population. Few people are aware of the anglers' important social and ecological role. Angling still bears the image of a hobby for old men, but this is no longer up to date. Anglers take care of water bodies and their inhabitants in a large number of ways. For example, they engage in renaturation projects and clear debris from the shorelines. One important management measure applied everywhere is fish stocking. In the year 2010 alone, German angling clubs collectively invested over 20 million euro in releasing fish that had been bred or wild fish caught elsewhere. This was the result of a survey by the Leibniz-Institute of Freshwater Ecology and Inland Fisheries. Truckloads of carp, eel, pike, sander, salmon, trout, roach or bream and other species popular for anglers, and even small endangered species, are put into our rivers, lakes and ponds. But does this hard work really bring the success we want? It is difficult to predict the chances of success for fish stocking. The ecology underwater is complex and intricate. The critics also point out that sometimes populations from areas far apart are brought together into contact. This can lead to undesirable side effects, such as introduction of diseases or hybridization of non-native population with native ones. So fish stocking could result in the loss of genetically adapted populations. Measures that practitioners regard as normal and necessary alarm some environmentalists and are also the subject of critical scrutiny by Fisheries Professor Robert Arlinghaus. The solution to this problem involves solving an ideological conflict. Managers of angling waters naturally have two main targets. Firstly, the support of angling, and secondly, the development of natural fish stocks. This is also stipulated under fishery law. And here is an example of the fisherman's interests. Someone may want to fish for carp in his waters and to cultivate it in large numbers. Usually he will use stocking, since carp don't normally recruit naturally so plentifully in German nature. Releasing carp is then good fishing practice from the fisherman's point of view. On the other hand, environmentalists often reject the very same practice strongly because it allegedly involves the release of a non-native fish, and because the fabric of nature is supposed to be altered by the stocking program. Moreover, carp could possibly have negative effects on the quality of water, because the species uproots the sediments during foraging activities. In fact, we know from the literature that this is only a possible problem, from 150 kilos per hectare. But the fact in itself that carp are stocked already leads to conflicting opinions.
Der Fakt an sich, dass man Besatz mit Karpfen macht, führt dann schon zu konträren Positionen.
It is high time to use facts to resolve the controversy between nature conservation and the interests of fisheries. That is the opinion of a number of young researchers from the Leibniz-Institute of Freshwater Ecology and Inland Fisheries in Berlin, in short IGB. In 2010, they established the research project Besatzfisch and make it their goal to separate the good stocking procedures from the bad. The scientists plan to spend 4 years investigating the ecological and economical impact of fish stocking in German recreational fisheries. This is their main imperative. The anglers should be brought on board from the very beginning. The goal is to research and to learn from each other. Furthermore, the project group aims to examine its methods for this hand-in-hand approach critically. Does an exchange of knowledge take place? And if so, how can this be best organized? The Federal German Ministry of Education and Research likes the plan. Stocked fish is sponsored within the program for social ecological research. All their sponsored projects have 2 special features. Firstly, the researchers are not restricted by traditional divisions between subjects. Their research is interdisciplinary. This is rare in science, but fundamental for research that seeks sustainable solutions to environmental problems. So in the stocked fish team, fishery biologists, sociologists and psychologists work hand in hand. Secondly, the research group, led by Professor Dr. Robert Arlinghaus, conduct research and learn together with the anglers in their waters, featuring a transdisciplinary research. Let's forget the ivory tower and get down to work locally. Of course, we had examined recreational fisheries and had contact to anglers in the past, for example, when they took part in surveys. But scientifically developing research questions together, carrying out joint experiments on the waters, harvested by the anglers. This depth and intensity of cooperation was something completely new. In environmental sciences as a whole, this is a brand new branch of research, social ecological research, where the people concerned on site are not only viewed as informants, but as an important part of the process of gaining insight. Otherwise, we scientists cannot profit from local know-how, since there may be problems on site that we don't know about. Here, the people on site are crucial components of the solution to sustainable fisheries. Accompany the stocked fish team and their angling clubs on the road to sustainable water management, a research journey right through the depths of our water. And we humans do not come off too badly either. The members of the Angling Sports Club throughout Bramsche. From early 2011 onwards, they take part in the Stocked Fish project, together with 17 other angling clubs in Lower Saxony. The collaboration is laborious. The anglers' voluntary service lasts over 3 years. On many weekends, they offer unpaid support on field experiments, attend workshops, and patiently answer the researchers' constantly repeated inquiries. The Stocked Fish project is looking for answers to these questions. Can stocking really increase fish populations and the anglers' catch? Does fish stocking involve genetic and other ecological risks? When should stocking be avoided and when is it advisable? What are the alternatives to fish stocking? Through their participation, the anglers learn how to adapt their management and make it more sustainable, i.e., more effective for fishing, lower risk and economically more efficient. What did I gain from it? Many new insights that I didn't have before. Before this, I always went to the water, hooked my dead baitfish, threw it in, and that was it. I was interested in everything that's done with the DNA samples. I was an enthusiastic participant every time, for example, during the electro-fishing events. I think things will change. People will view the politics of fish stocking differently. For example, that it is sometimes useless in the case of fish-eating predatory fish species.
Ja, einen wunderschönen guten Abend.
Regular seminars and workshops play a constant part in the overall research project. Here, scientists and anglers share their experiences and plan experiments together. But a bit of theory is necessary. For example, the researchers explain the principles of sustainable fish stocking, and clarify why they suggest performing stocking experiments with the model fish species pike and carp. For what reason? Fish species like pike normally reproduce in their native waters, independently of stocking, if sometimes at a low level. Pike rely on aquatic and shoreline plants for this. Roots and submerged plants offer the newly hatched spawn protection from predators. Highly developed water bodies no longer offer refuge. The spawn disappear before they have the chance to grow into spawning adults. Here, stocking serves to redress shortages in natural reproduction. It can also compensate for intensive fishing. Compensatory stocking is the term for the type of stocking that takes place in fish populations that are still reproducing naturally, but at a low level. This kind of stocking is also common for other species popular with anglers, such as zander and brown trout. It is therefore important to check the chances of success of compensatory stocking, using the example of the pike. The procedure is different in the case of fish species that are not naturally found in water bodies. This group includes, for example, carp or eels in enclosed lakes, which would have to return to the sea to reproduce. Without stocking, these species would disappear from the water bodies. Experts call this maintenance stocking. This is also common in recreational fishing, for example for carp and rainbow trout in lakes, and should also be examined by the stockfish team for its chances of success.
Die 1171.
In order to carry out the experiments with carp and pike, Team Stocked Fish works particularly intensively with 5 of its 18 collaborating clubs. By the end of the project, the anglers from these clubs should be able to plan and carry out the so-called adaptive management of fisheries by themselves. What does this mean? Good water body management focuses, following with statutory specifications, on the goals of the angling club and the characteristics of the ponds, lakes and river sections. But there are so many special features on site that no textbook in the world could cover exactly the correct procedure for each case. What is correct is relative and depends on a complex interactive structure that varies from water body to water body. Furthermore, the outcome of measures like fish stocking is not entirely predictable. Ecosystems are subject to random environmental factors, such as a fall in temperature in spring during the spawning season, or unforeseen fluctuations in water level. Therefore, modern ecosystem management is a constant learning process. Every procedure is an experiment, and both success and failure are important experiences on the path to optimal management. This is the basic principle of adaptive management. There are useful flowcharts for the optimal setup of this kind of learning by doing approach, which were developed and put into operation together with the anglers. In nature, everything is quite changeable and unpredictable. You can't identify the best management procedure at the start. So you always have to regard management as an experiment. Adaptive management means that you make a well-structured process to identify a certain measure in the light of previously defined goals and objectives. It means weighing up this measure with respect to its probability of success, perhaps also taking alternative measures into account, and then carrying out and evaluating the measure. So you really have a means to monitor success, to see whether the result is success or failure. And by circular reasoning, this may lead you to adapt your future objectives. This is the ideal process. Since there is a high degree of uncertainty, you don't know whether fish stocking will be successful or not. Nature is so changeable. There are very many influencing factors that cannot all be foreseen. And that is precisely what adaptive means. That you are always able to adapt to new conditions by learning from the past.
Adaptiv, das heißt, man ist immer anpassungsfähig an neue Bedingungen. Ja? Und das ist so die Philosophie dahinter.
In the course of the project, researchers and anglers go through the 4 central points of adaptive management together. The stocking experiments with pike and carp serve as examples. but the basic principle behind this applies generally. It can also be used to plan harvest regulations and rehabilitation projects. The goal of Stocked Fish's cooperative experiment is to increase the pike and carp populations through stocking. But in order to carry out comparable experiments, the ecological condition of the water body must first be examined. Together with the local angling club, fish biologist Daniel Huhn and his team of helpers carry out an analysis of this type in spring 2011. They examine pH values, oxygen content, nutrient content, and of course the structure of the water body regarding vegetation and the availability of other possible hiding places around the banks, particularly important for young pike. In this echo sounding we record the structure of the waterbed. Here you can see the depth of the water, and the water temperature is also recorded. With the help of these data, we can chart the depths and also measure the degree of aquatic plant coverage. In addition, the biologists use electrofishing and gill netting to find out how many fish already live in the water body and whether they are reproducing naturally. This information is of interest to angling clubs. It is not often possible for them to carry out such technically complex investigations themselves.
Wir fanden das erstmal schon ganz klasse.
We thought this was great. It gave us a lot of information about our water body. Water body analysis and monitored fishing were done. For the first time, we could see what population we have and what the structure and water quality are like. It's great to know all this. Now we can plan our fish stocking for the coming years, and we can see how to improve our water body and manage it sustainably.
Auch nachhaltig hier vernünftig zu angeln.
Both water bodies with a rich structure and high nutrient level, like here in Stable by Lüneburg, and anglers' water bodies with poor structure, were both included in the stocking experiments. The researchers have an idea that pike is a cannibal. It lives by the motto, large eats small, and does not even spare its own kind. So young pike rely on hiding places, for example among aquatic plants. The newly hatched pike's aim is to survive this critical phase and to grow to become a large fish that no longer lives in fear of predators and can reproduce. If a large number of pike are already living in the water body, the chances of finding a good refuge after being stocked sink, and the probability of being eaten rises. There is a high degree of rivalry within the species. The researchers suspect that stocking a water body with a large degree of vegetation, i.e. a water body with rich structure, where many pike occur naturally, is ineffective. The newly hatched fish are simply eliminated. This is their theory, but it still needs to be checked. But what about water bodies with poor structure and fewer aquatic plants and vegetation at the water's edge? Do stocked pike have a chance when they do not have to compete with naturally occurring rivals? Or is it also the case here that foreign fish fall by the wayside because there are few possible hiding places? In the workshops, stocking's chance of success was the subject of lively discussion. Airing differences of opinion is desirable for adaptive management. There's a high degree of uncertainty. Although this is sometimes hard to bear, it is also the driving force of a learning-by-doing approach.
Nee, da haben die da komplette Brücken reingehauen.
Das liegt auf jeden Fall nicht.
Das ist Bauschutt, aber das ist sehr positiv. Nee. Das ist sehr, also für Unterstände sind da genug drin, durch den Bauschutt. Ne?
Team Stocked Fish were interested not only in the current biological status, but also in the anglers' attitudes and opinions. Indeed, their needs and ideas are just as important for planning and assessing stocking procedures. This task is like the terrible struggles of Sisyphus for the workers in Team Stocked Fish. Kilograms of questionnaires have to be packed up, addressed, sent, and later evaluated in painful detail. After evaluating the huge amount of data, one thing is clear. The majority of anglers think that stocking makes sense, even in the case of pike. Furthermore, special pike stocking is regarded as very successful. This is proof not only that fish stocking is a major, important topic in angling fishery management, but also that an experiment on the chance of success of pike stocking is relevant for anglers. The questionnaires results also clearly show how seriously Germany's recreational anglers take their responsibility for management and fish conservation. They invest a lot of time and money in procedures to support the fish populations. Evaluation of the success of stocking is very meaningful for both ecological and economical reasons. Back to the angling club, Frühaufbranche. In autumn 2011, stocking was planned based on fish biological data on the current state of the club's water bodies. Side by side with the scientists, the anglers determine the amount of carp and pike stocking and predict the expected success rate. Will fish stocking really lead to a sustainable increase in the population? Will the stocked fish eliminate the wild fish? And is the expense-effort ratio acceptable? Some anglers are worried about overstocking. Others want to develop certain water bodies for fish other than pike and carp. By the end of the discussion, well-grounded solutions have taken shape. This type of collective decision-making is essential for adaptive management.
Also Temperatur auch okay, ja.
Echtsee ist ganz klar und sowas. Der wäre auch vor, wenn das Hochwasser kommt wie letztes Jahr, höhere Gewalt, dann sind wir... das können wir ja nicht vorausplanen.
Lively discussions open the angler's eyes to the great complexity of a fishery management and the topic of fish stocking. They already know a lot from good old gut instinct. Many things have always been done this way. But the research project Stocked Fish makes them consciously aware for the first time of many things they knew unconsciously. What we really want to do is to pass on the philosophy of adaptive management to the clubs. We have gone through the process once with the example of fish stocking. But the club should of course internalize this process for itself. Perhaps the minimum size limit will have to be raised in the framework of catch limitation. And there is a group of anglers who are in favor of this, but others who are not. The result is uncertainty about the likely effects. Using the tool of adaptive management, the club is able to do its own experiment, for example, by raising the minimum size in some water bodies, but not in others. By recording and evaluating the catch and harvest, one can find out whether the measure has had an effect.
Das war die 40. 4741.
And now we come to the crutch. Under the eagle eyes of the anglers, Daniel Huhn and Thilo Pagel from IGB Berlin stock the Buschmühle Lake by Helmstedt. The Buschmühle Lake is a water body that offers pike many hiding places and chances to reproduce. The Buschmühle Lake has a very good pike population, and we want to see if we can increase it even more. But practical experience tells us that the numbers in a well-stocked lake cannot be raised through stocking. This is what we are going to test here. So it is no wonder that the team came across a naturally large number of young pike in the Buschmühle Lake. By stocking at a rate of 70 young pike per hectare, the population of young pike in Buschmühle Lake was artificially doubled. Will the large number of fish introduced survive? And will stocking contribute to an increase in population? The researchers' assumption is that stocking will lead to rivalry between young pike. The increased size of the population will be adjusted by cannibalism to reach a young pike population number that fits the water body, each with its own number. In this way, the individual fish can be identified by the researchers or anglers on recapture, and survival and growth rates can be determined as indicators of the stocking's success.
This
one's got the number 6514. First, it gets an internal tag. This is a little chip like the ones dogs and cats have. I insert the chip under the skin of its neck, and now I can read it using this device. And this fish has the number 6255. As it is hard for the anglers to identify them like this, each fish is tagged twice. To help the anglers, I used an external tag with these little Floyd tag flags. They are placed between the spines of the fins. This fish's number is 2559.
2559.
The Leibniz-Institute of Freshwater Ecology and Inland Fisheries in Berlin. Here, the scientists from Team Stockfish prepare the practical experiments for the angling clubs and supplement them with their own experiments. A very special and technically extremely complicated experiment provides an insight into the behavior of stocked fish underwater. For this purpose, adult pike from the lake under observation and non-native pike from 2 other water bodies are fitted with tracking devices. The aim is to find out whether the newcomers can hold their own against the old-timers and how they behave after stocking. It is particularly interesting to see whether the non-native pike reproduce in their new waters, thereby contributing to the future pike population. This is totally new ground. Of course, there's the question of whether local adaptation occurs, i.e. that fish adapt to the water body, both genetically and in their behavior, and then should be able to outdo newly introduced non-native fish. This is exactly what we want to check, whether this is the case or whether it is completely different for pike, since genetically the fish that we introduce here come from a similar region, have experienced similar water bodies, and maybe will get on just as well in their new environment. We really want to see whether stocking relatively robust fish is a success or not. A complicated question that can only be answered with complicated technology. For this end, the pike are fitted out like high-tech champions. The researchers implant tiny 12-gram acoustic transmitters in their abdominal cavities. These are used to ascertain the fish's position later on. DNA is used to match up offspring with their parents, to measure the success of reproduction. After less than 3 minutes, the operation is over. The abdomen is sewn up and the patient moves on to one of the many lakes under observation by Berlin's Leibniz-Institute of Freshwater Ecology and Inland Fisheries. Here the tagged pike are released. To top it all, some native pike had also been caught, transported and put into the same water body. Thus, the team can measure the effect of transportation stress. The lake, on average 4 meters deep and 25 hectares in size, is an idyllic spot. 20 underwater microphones are in operation to receive and save the ultrasonic signals from the fish. With the help of these hydrophones, the signals from the acoustic transmitters implanted in the pike can be received. Using these hydrophones and the different arrival times of signals at least 3 hydrophones, we can determine the position of the pike.
Mindestens 3 Hydrophonen können wir dann den Aufenthaltsort der Hechte bestimmen.
Using triangulation, every pike can be relocated, and its behavioral patterns and movements can be studied. Here is the researchers' most important discovery. In the first winter after stocking, all stocked pike had lower survival rates than the native animals which had not been put under transportation stress. While all the native pike survived until spawning season, only 80% of the stocked pike, regardless of their origin, managed to survive the first winter. So even large spawning fish cannot cope well with the stress of stocking and transportation. However, the surviving stocked pike reproduced at roughly similar levels to the wild pike, and so contributed to the next generation of fish. Those spawning pike that settle down after stocking can help maintain the population level through reproduction. but depending on the origin of the stock, they can also contribute their non-native genes by crossbreeding with native spawners. Another of Team Stockfish's projects involved methods merging on criminology. Armed with pipette and test tube, the scientist Dr. Eric Eschbach investigates the blood relationships of pike and also zander. This is the question on his mind. Do local populations adapt genetically to their environment? If not, there would be no genetic risks in stocking these species. But if so, there are two possibilities. Firstly, stocking non-native fish that are genetically less well adapted is problematic. Native fish are perfectly acclimatized to their habitat. They are strong and healthy and successfully produce many equally strong offspring. Crossing native fish with stocked fish adapted to different conditions can weaken the population in the long term, since this results in offspring that survive less well in the water body. Secondly, stocking non-native fish that are genetically less well adapted is ineffective. The non-native fish may be unable to hold its own against the native fish in these circumstances. Crossbreeding does not even occur. In principle, I am performing these genetic analyses with the aim of looking for distinctive features between the populations, if any, using genetic markers. This point was previously unclear because a lot of stocking was done, which can potentially result in the population assimilating genetically. This causes homogenization, which is exactly the opposite of what nature aims for, namely to maintain a certain biodiversity, even within the species. Now we want to see whether genetic biodiversity still exists in the various large river systems, or whether stocking has more or less resulted in uniformity that can no longer be genetically redressed.
Oder ist das durch Kreuz- und Querbesatz alles mehr oder weniger eine Einheit geworden, die sich auch gar nicht mehr genetisch auflösen lässt?
Fin samples should give us the answer. With their help, Eric Eschbach examines, for example, whether wild fish in the angling club's water bodies genetically match their neighbors, or whether they have a completely different genotype. This means hard work in the lab. The molecular biologists collected samples from pike and zander from almost every large river in Germany. Hundreds of jars of fin samples from pike and zander pile up in the archives of the Institute in Berlin. Here we have reached about 2,500. This one, for example, is a pike sample from the Danube. We've got samples from virtually every big river, which we can study to see how diverse the pike populations in Germany are. Each sample brings its own individual genetic fingerprint. Only in this way can we develop a kind of family tree for each species of fish under examination. Team Stockfish's unique aim brings astounding results.
Also das war ein bisschen überraschend für uns auch. Man sieht jetzt, dass
This was a surprise for us too. We can now see that in the cases of both pike and zander, you can find 3 genetic lines, which in turn can be assigned to the catchment areas of the Danube, Oder and Elbe. And in these areas you can find the matching genetic contingents. In the Danube, for example, the Danube contingent is very high. And we see that in the other catchment areas, in particular the Rhine catchment, we come across a mixture of the 3 genetic lines. This is rather surprising, since after the Ice Age, the dissemination of pike and zander were very different. The zander only reached the Oder and Elbe, while the pike spread further. So you would expect there to be more genetic lines, and that these genetic lines would be more mixed. This would have been more typical of the pike, since it is known to be not as diverse genetically as other fish species.
Genetischen Linien einfach mehr vermischen. Und das wäre eigentlich auch das Typischere gewesen für den Hecht, weil dort auch bekannt ist, dass der genetisch nicht so variabel ist wie andere Fischarten.
Despite intensive stocking in almost all Germany's water bodies, you can still find clear genetic lines that differ distinctively from each other. But there are also signs that lines that were originally separate are mixing genetically. an unmistakable sign that natural barriers are being broken down through stocking and connecting the waterways across catchments via canals.
Ja, man kann vielleicht noch schlussfolgern, dass wenn
one can conclude that where non-native stocking has occurred, for example pike from the Danube, their genetic makeup has not taken hold. On the basis of this, one can in turn infer that maybe it doesn't make sense to stock non-native pike.
Vielleicht der Besatz mit solchen gebietsfremden Hechten wenig Sinn macht, weil sie sich eben nicht durchsetzen.
The best way to minimize both risk of disease and genetic risks is to breed the local population itself and later introduce it again into its own waters. But the technology and opportunity of breeding, raising and returning one's own wild fish to the water are hardly feasible for most angling clubs for reasons of time and money. However, this is still the best way to maintain genetic diversity in one's local water body. In Emden, on the North Sea coast, an angling club and a professional fisherman together carry out a showcase of this kind. Here, young pike from their wild population are bred. However, this does not necessarily mean that they grow within the population, survive and increase the population. Perhaps the natural offspring of the wild pike are already strong enough to rival them, eat and eliminate them.
Zweitens mehren sich die Hinweise,
there are many signs of carryover effects of being held for even short phases in unnatural conditions, for example in an incubation jar. This high density and relatively unnatural environment results in the fish not being optimally adapted to survive in nature. There is a high mortality rate for these animals in the first days after stocking.
Dann in den ersten Tagen nach dem Besatz eine hohe Sterblichkeit erfahren.
Indeed, an experiment by Team Stockfish in ponds showed that pike fry came off worse when in competition with naturally occurring animals with the same genetic origin. Stocking pike fry did not increase the number of fish. The numbers were similar to those in control ponds where no stocking occurred, and pike bred naturally. By the end of the year, the stocked fish, which were produced in the pike spawning facility in Emden and then released into the pond, were only half as big as the wild fish. This, together with their distinctly higher mortality rate, was a clear indication of the inferiority of artificially bred young pike. Back to the anglers in Lower Saxony.
Wir fangen hinten an der Boje.
From spring till autumn 2012, the scientists from IGB Berlin are permanently on the road, recording the success or failure of the stocking procedures in a total of 18 lakes belonging to the participating angling clubs. Over 30,000 kilometers back and forth through Lower Saxony, from Helmstedt to Schönewörde and then on to Bramsche, Peine and Stapel. In 2012, Thilo Pagel and Daniel Huhn went to find out how many of the tagged pike in the water bodies have survived, and how large the population of the stocked fish is compared to the wild fish. For this end, electrofishing is both a gentle and elegant method, although it only works near the bank. In a circumference of several meters around the anode, the electric current stuns the fish and thus brings them to the surface. When the researchers have caught enough fish, they return to land. Here they examine their protégé in detail. Thanks to the tags, Daniel Huhn can distinguish the stocked pike from the wild fish using a scanner. At first it looks as if a large number of stocked fish have survived, but by the end he sees that stocking has only been a success in very few exceptional water bodies, and only in the short term. After only a few months, the population returns to its original level, so stocking pike was useless.
Ist auch ein Wiederfang mit 9.
This is a fish we caught again with the number 6962. To double-check the results of the catch, the researchers from Team Stocked Fish do not rely only on their own results. They also examine the angler's catches very carefully. An additional further evaluation of the fish stocking is performed using hundreds of specially designed angling diaries. Does the catch increase after stocking? Particularly for carp, the scientists rely on the catch diaries, since this fish cannot be documented well electrically. The clever carp also happily avoid nets. When the anglers note down in their diaries not only the catch, but also the time of fishing, we get very precise information on the actual fish population of a water body. This is a practically important result of Team Stocked Fish.
Wir würden als Projekt den Angelverein raten.
We would advise the angling clubs to record the catch per angler and per time spent fishing. This is a relatively simple measure that every angling club can carry out. Then the number of fish caught should be divided by the time spent fishing to reach an average value for all the club's anglers. So we were able to show that this is a very good way to measure the development of the fish population. And so it helps to improve its management.
Angler im Angelverein zu ermitteln und ja, wir konnten eben zeigen, dass dies als ein sehr gutes Maß eben für die Fischbestandsentwicklung dienen kann und von daher eben eine Verbesserung der Bewirtschaftung ermöglicht.
By the end of 2012, the first results are clear and are then presented and discussed in the 5 angling clubs.
Und im Prinzip haben wir vermutet, dass wir in strukturärmeren...
Firstly, we suspected we would have fewer pike in total in the water bodies with less aquatic vegetation and other structure. And secondly, that stocking would be necessary to achieve population increase, especially in these poorer water bodies, for example here in Horst Lake.
Genauso wie ihr gesagt, da passiert kein Effekt. Aber in strukturärmeren Gewässern sehr wohl. Also zum Beispiel im Horst.
With the angler's catch in mind, carp stocking was a success. The catch rose in proportion to a rise in the quantity stocked. But in the case of pike, stocking was successful only in the very short term, to the surprise of the anglers and scientists, who had only had a slight suspicion of this. The joint assessment in the 5 angling clubs was met with amazement. After only a few months, the pike population fell back to its original level. Pike regulate their own numbers through cannibalism, to a level that the water body can support. The water body's so-called ecological carrying capacity. This varies from water body to water body, but cannot be increased by stocking. When reproduction is taking place, the pike population cannot be raised by stocking. What is striking in the case of lower and higher stocking density is the short-term peak, quasi-stocking success, and then immediately a drop to the original level. You can see this everywhere. But thanks to tagging, the scientists could prove that the composition of the population had changed. There are several stocked pike among the population now, although the size of the population is the same as before stocking. In other words, some newcomers have established themselves without raising the population numbers. Daniel Hume presents these research results to the anglers in clear terms. Pike stocking has been shown to be a completely useless procedure for fishing, since the fish numbers remain the same. But the population's composition changes after stocking, which means a risk from the point of view of nature conservation. The loss of genetically adapted fish through stocking, especially when a large number of stocked fish from non-local origin are put together with relatively few naturally occurring fish, which inevitably leads to crossbreeding and mixing of the population. Indeed, we had the hypothesis that pike stocking is relatively ineffective, but we were not at all sure. Particularly the stocking of larger animals could have led to success, or stocking in water bodies with few natural offspring. for example those with poor structure of shorelines. There we would have expected pike stocking to have a good success rate. We too were surprised to see that, no matter in which water body, no population increase occurred. From a scientific point of view, it was surprising to see this with such clarity. The great thing was that we used 18 water bodies, and therefore these results are not only based on random effects in single lakes.
Auf einen Zufallseffekt in einem bestimmten Gewässer zurückzuführen sind, sondern tatsächlich stabil sind über alle.
Over a period of 3 years, researchers and 5 angling clubs went through a cycle of adaptive management. Another 12 clubs took part in seminars and surveys. In total, Team Stocked Fish had 95 workshops and over 100 fishing expeditions. About 1,000 anglers kept an angling diary, and thousands of questionnaires were sent back and forth through Germany. The newly won scientific insights are now gaining acceptance in specialist literature, and Stocked Fish's postgraduates are gaining their doctorates. Over 90 scientific papers were written in the last 4 years. But what about the anglers? Have they gained anything from the project? With the help of questionnaires, social scientists from Team Stocked Fish have critically examined their hand-in-hand concept. After evaluation, this is certain. At the start, there was a large majority in most of the clubs who thoroughly believed in the success of pike stocking. But by the end of the Stocked Fish project, this percentage had sunk considerably. They had truly gained in knowledge. They gained factual knowledge particularly well in the classroom and through seminars. For example, that the survival probability of large fish is higher than that of small fish. That fish from local populations are better adapted to their water body than non-native fish, or that stocking can also have negative impacts. But an overall change in the management philosophy that accepts alternatives to stocking was only achieved through intensive joint work and through experiencing the results in person. I was surprised which water bodies this is true for. I would have thought that especially in waters that are rich in nutrients and prey fish, one could raise the pike population through stocking. But that was wrong. I was one of those who was vehemently and vociferously in favor of stocking of pike. And I had very intense arguments about this.
Naja, ich will nicht sagen, alle Köpfe gehabt, aber doch sehr intensive Diskussionen geführt, sagen wir es mal so. Und
and now, after this project, I have to revise my opinion. I was wrong.
Wir haben ja schon eher so darüber gesprochen, muss ich meine Meinung revidieren. Ich war falsch.
Auf der anderen Seite der Karpfen.
In the case of carp, it was exactly the other way round. Their stocking was very successful. The more stocked, the greater the anglers catch. A clear indication of additive effects that increase the population. The big difference results from the preconditions. In the case of pike, we have a competitive situation with wild recruits. There are natural limits for its numbers, and you can't just evade these limitations by stocking. But in the case of carp, there is no internal rivalry because there are no wild recruits. Furthermore, carp are very strongly competitive against other fish. Under these circumstances, fish stocking can be successfully carried out. This is also the case for eel or rainbow trout in lakes. Other examples of the pike situation would be sander, brown trout, and other predatory fish. Here there is simply a natural occurrence, and probably also a natural limit for the population size. When this is the case in a water body, you can't raise the population by stocking. As a consequence, the anglers should reassess these procedures critically and spend their money on other procedures instead.
Geschichten zu stecken.
So stocking is not always a potential success. In accordance with the concept of adaptive management, The next step is to formulate new objectives and procedures. But what alternatives are there? Apart from fish stocking, the angling clubs have two further ways to increase their fish populations. One is improving the habitat itself. By introducing dead wood, encouraging the growth of vegetation, or rehabilitation of natural water courses, perhaps in cooperation with nature conservation and environmental authorities, they can create places for spawning and for refuge, and thus raise the water body's maximum load for the species desired. Sanctuaries, closed seasons, and size-based harvest regulations all have an effect on the fish fauna. Here are many potential means of improvement. For example, currently set minimum size limits, which stipulate what size of fish the angler is allowed to take out of the water. Protect in particular small fish that are still maturing. But the leader of Team Stockfish, Robert Arlinghaus, is convinced of this. Protecting large, robust spawning animals is equally important for the maintenance of a self-replicating fish population. This is his suggestion. Instead of a minimum size limit, introduce a so-called harvest slot, which forbids the removal of both the very small and very big spawning fish. As a rule of thumb, only those fish that can pass sideways through the window may be removed. This is why the term kitchen window is also often used instead of harvest slot. But the effect of this still remains to be discovered. There is still a lot to do for the anglers and the scientists. To summarize, when certain conservation procedures' chances of success and risks are unclear to the club, the only thing to do is try it out in the club's own water body. The key to success is using the steps of adaptive management as a guideline. This involves a precise analysis of the current state and, based on this, a formulation of objectives, weighing up procedures and their risks, later checking incidences of success, and perhaps correcting the objectives and procedures. These are the important basic cornerstones for economically and ecologically meaningful management of a water body in the long term. But can the angling clubs in future carry out adaptive management independently without expensive scientific methods? Team Stockfish wants to champion this cause. What are the options? A small but valuable experiment by Stockfish shows how the angling club's know-how can partially replace complex analysis, tagging and electrofishing. During the seminars, the anglers were asked to estimate their numbers of pike. In 15 of 18 water bodies, the anglers' average estimates lay within the scientific margin of doubt. This means that they could quantify the fish numbers merely through observation, without scientific assessments. Incorrect estimates mainly occurred in the cases of very small lakes, where the numbers were often overestimated. The values were more precise in groups where intensive discussion took place before an estimate was made. This was a surprising result for the researchers. The idea of so-called swarm intelligence is nothing new. This is the underlying principle here. But the fact that one can measure so precisely an uncountable resource like fish, who is in the water and swims around unobservable, using an average value estimate from so many different people, indeed it was very, very close to reality, was phenomenal. Catch diaries can serve as an alternative method of monitoring. By noting down the success of his or her fishing, every angler can contribute to the catch statistics. However, here the researchers from IGB have another important tip. One must record not only the catch, but also the fishing times. Only then can conclusions be reached on the development of the fish abundance. This important detail is often neglected in practice, where absolute landings are often the only recordings.
Und warum eben diese gefischte oder die
Here is a clear explanation of why it is so important to take the fishing times into consideration.
deutlich, wenn zum Beispiel ein
If, for example, an angler caught 10 carp one year and only 1 carp the next year, one could quickly come to the conclusion that the population numbers have fallen greatly. But it could be the case that the angler fished 10 times more in the first year, and so the catch would be identical. That is, the number of fish per unit of time would be the same, and so the population would also be the same.
Zwischen den beiden Jahren gleich, also der Bestand auch gleich.
Therefore, the catch must be divided by the time taken in order to reach comparative results.
Und das sind genau
It is exactly in cases like these where adaptive management steps in. An angling club may say, for example, we've got an alternative to pike stocking. Our goal is to raise the fish numbers, and we've got the choice of a combination of methods. We can choose between introducing dead wood, setting up sanctuaries, using the kitchen window method, or raising the minimum size limit. One is uncertain which of these procedures will lead to success. This is exactly the type of situation where one can use adaptive management and say, I'll try out the kitchen window in 2 water bodies. In another 2, I'll change the composition of the banks, and I'll monitor the success rates, perhaps through the numbers caught, to see what happens.
Was passiert?
Team Stocked Fish is convinced that every angling club can do this, either independently or together with the association's biologists. You learn from every attempt. That is a core message of Project Stocked Fish, which draw to its end in summer 2013 with a joint evaluation. For the participating angling clubs, the diverse scientific experiments with electrofishing or water body composition analysis, the joint planning committees and the stocking of pike and carp, attended by the Leibniz-Institute of Freshwater Ecology and Inland Fisheries, provided a unique opportunity to get to know their water bodies better. Just taking part in a project like this is great. It's a once-in-a-lifetime experience. We've got 1 or 2 water bodies where the stocking policy isn't that simple, so scientific support is important here. The question of fish stocking is not yet well resolved in Germany, so a project like this is very important. It's a good thing. The Stocked Fish project was carried out in Germany, mainly in Lower Saxony. But the topics of fish stocking extend beyond Germany.
Some background on the population settings that I want to give you.
Stocked Fish's annual scientific meeting is attended by guests from England, USA, Australia, and Japan. Why is this? In particular, the all-embracing perspective that goes beyond individual scientific disciplines, so-called interdisciplinary research, and the joint learning experience with users, so-called transdisciplinary research, meet with approval.
Yeah, I think what has struck me over the last couple of days finding out more about the project is that it's interdisciplinary, transdisciplinary, but not in the usual sense of the word, because in my experience, most fishery professionals don't have the capabilities of doing that sort of work. That Robert's group, I think, has been able to push the envelope or work in a very sophisticated way in a variety of aspects of fish stocking. Individual investigators may usually focus on one thing, such as the social science or the economics or the ecology. And this group is really looking at all the relevant pieces to the problem of fish stocking.
It's accepted internationally too. Projects like Stocked Fish that go beyond the barriers between disciplines to tackle problems and involve the practitioners on site are the future of sustainability research. Stocked Fish shows researchers and practitioners together, supporting the sustainable use of natural resources. It's worthwhile, since in this way much new know-how is generated, which can immediately be put into practice without a detour through the scientific literature.